So welcome to my YouTube lectures. So today let us talk about some autonomous system and their properties of their vector fields. Autonomous system, autonomous dynamical system. A first order differential equation is said to be, an autonomous system. Says this first order differential equation, okay, it is of this form. It is said to be an autonomous system if the right hand side it is a function of the dependent variable only. So independent variable is not involved here. Okay, so this independent variable time is not involved here, only dependent variable is involved here. So such type of differential equation or dynamical system is said to be an autonomous differential equation. So let us briefly see. So what is nature of the vector field of such type of differential equation? Okay, so yeah, first let us see. It is so that the vector field of autonomous system is parallel for a given x. So you are going to draw the vector field in the x t plane or in tx plane. So for a given x, you keep on changing different time. For a given x, you keep on changing for different time. Now say, in fact, let us see here. So for a given value here, x is given here. This is fixed. So when time changes, if you start time from here, then you can think about one solution curve starting from here. Okay, then if you for same value of x you change the time here, then you can also start think about a solution starting from here, taking this one as an initial point. You can think. So for autonomous system, what does it say is that for a given x, so you keep on changing t. That means you take points on the horizontal line in this way. Then the vector field at each point, they are parallel. Okay, the vector field or the direction of the tangent to the curve at this point is parallel to the direction of the tangent at this point. Okay, so you have a set of tangent vector field here. So they are parallel. Okay, they are parallel. So that is the thing. So it is very easy but very useful idea for further study. So let us see how it works here. So for a given x we have let us prove it. For a given x we have this this is the slope then of the theta, where theta is the angle made by the theta is the angle at the point you join with the origin. So the angle made by the line joining the origin and the point to the x-axis, that is theta. Tan theta of this one is dx by dt. This is called the slope, is equal to bx. Okay, is equal to bx. All right, this implies that tan is theta is equal to tan inverse of bx. All right, so it is independent of the independent variable time. Okay, it is independent of the independent variable time, so there is no time variable involved here. So for every value of t, this is fixed. That means direction is fixed. Okay, direction is fixed. All right, so that is the idea. So since vx is independent of the independent variable time t, we have same theta for all t. Okay, we have same angle. Theta means same angle for all t. All right, so what does it mean? What does it mean? So as I already explained, if you take this point, then you take different value of time here, and then the direction, this direction, this is the direction, this line segment represent the direction of the tangent vector at this point, you know. So this also represent the direction of the tangent at this point, line segment response. This one and this one are parallel. That means the angle subtended by this line with the x-axis, okay, with the x-axis. Suppose this is like this will be theta, okay. That is equal to the angle subtended by this line extending with the x-axis. All right, so fix one. So that means the tangent vector, they are all parallel along this line only. It is a set of parallel line. The tangent, you know, it is the tangent vector, the set of tangent vector along this line, okay, they are parallel. Because here also, if you take a point here, then I draw a horizontal line parallel to the, you know, time axis. So at any point here, the tangent vector or the direction of the tangent is parallel to this one and this one. They are all parallel, okay. So that is the idea. For autonomous system, for a given x, okay, the set of tangent vector is a parallel tangent vectors, okay. Right, so that is the case. Yeah, and next is, you know, next is show that the solution of an autonomous system, let us see, so that the solution of an autonomous system with initial condition x naught when time t is equal to t naught depends on the difference, this one, it is a function of this one, okay. So before going to this, you know, solution to the proof of this one, let us first, you know, see some example using the software. How does it, you know? So let us go to the, you know, let us go to the website. Site is here. Yeah. So autonomous system, here instead of t we are using x, and instead of x we are using y. So dy by dx form is here. So dy by dx is here. Suppose it is autonomous, so independent variable is not involved in the right hand side function, so only dependent variable is involved. So dependent variable here it is y. Let us see about y square, let us see, or y also. You can take for simple one y, let us take y, okay. Just enter the function value variable y here, click here, see, you can see here easily, you know, you can see. So you know, you can see when you think about this one, see at this point, you know, this is the curve passing through this one. But if you think about one horizontal line parallel to the t axis here, or here x axis, so this line segment, they are all parallel, okay. They are all, this is the characteristic of an autonomous system, okay. This is the characteristic of the vector field of an autonomous system, you know. So here also you see at any level, x is equal to something, you think about this one, this level, all the vector, you know, they are all parallel, okay. So now let us see one solution curve passing through this one. So it will be like this. Here let us see one solution curve here, it will be like this. Here it will be like this. All right, let us see how about here it is like this here. So like that, you see that one. So you are given a vector field, looking at the, you know, looking at the nature of the vector field. Suppose you just take one value of x, you think about, you know, a parallel line here, in this case dy by dx. So you take one value of y, then you just, you know, draw a parallel line passing through that value of y parallel to the x-axis, okay. So just look at the nature of the tangent, you know, direction, tangential direction or vector direction. If they are all parallel, then what is the conclusion? The conclusion is that the given differential equation is an autonomous system, okay. it is an autonomous. Okay, so this is the for the simple one, dy by dx is equal to y. Now let us see for the another a little bit complicated, not very complicated. So y square, let us see the vector field of this function. Okay, you just click here, then yeah, this is the vector field. Okay, clear all the graph first, then this is the vector field. Here also you look here, let's see, you think about value of y here, somewhere here. Okay, you think about value of y here. Okay, so value of y here. All right, then you think about one parallel line parallel to this x-axis here. You think about one parallel line here. So on this line, every direction of the vector, they are parallel. So this is parallel to this one, this is parallel to this one, they are all parallel. Okay, so this is the characteristics of what? Autonomous system. Here also you can see any point y is equal to, here also you think about y here, then think about one line parallel to the x-axis. So you will find that all the directions are parallel. Okay, they are all parallel. Here also all the directions are parallel like this. All right, so this is the characteristics of autonomous system. And then let us think about this is a point. You think about one point here. So what is the solution curve passing through this point? You just click here in the software, in this you just click here. So this is the solution curve. Okay, so let us see how about here passing to this one. This is the solution curve. All right, so like this is a solution curve here. And then how about here? This is a solution curve. How about here? This is a solution. So you can see all the solution curve here. Okay, for this autonomous system, the characteristics is what? For a value of y, you think about one parallel line parallel to the x-axis. Along that line there are lots of points. So on each point on the line, all the tangent directions are parallel. All the direction of the tangent, they are all parallel. Okay, so this is the characteristics of what? Autonomous differential equation. Okay, autonomous differential equation. If you take different value of y, what? So direction may be different from the earlier one, but all the direction of the tangents along the line, they are all parallel. Okay, they are all parallel. All right, so this is the thing, this is the property. So now let us go back to the our note. Let's see. So this is one. Let us go to the proof of the next result. Proof of the next result. Yeah, proof of the next result. Where is gone? Yes. So it is here. So that is solution of an autonomous system. Okay, with initial condition x is equal to x naught, when time is equal to depends on the difference of this one. It depends on this one. So that means it is a function of this one. It is very easy from the differential equation solving, but it gives some insight of the dynamical system. Okay, not only we are discussing the differential equation, but we are going to discuss the dynamics of the solution curves point starting from the initial condition. Okay, so when the function x is a function of it depends on t minus t naught. Okay, so what does it say? Let us see. So this is the autonomous system. Okay, so this is the autonomous system. So by this you can solve it by separation of variable. By separation of variable, what you get? This one. So suppose this is integrable. Let us assume that. Okay, let us assume that this is integrable. So this you can integrate. This side you can integrate already. So this is t minus t naught. So this can this can be integrated. Okay, so suppose after integration it is a function of it is a function of x only, and x naught will be involved here as a parameter. Okay, so it is a function of x. All right, so from this function f of x is equal to this one, you can solve x. Solution will be like this, where h is another function. Okay, or h is the inverse of the function f. right? So here x naught is a constant, it is, you know, for a given t naught it is constant. All right, so it depend, this x solution is depend upon t minus t naught only. Okay, so which is very clear, which is a function of t minus t naught. Okay, so what is the idea you have to remember for an autonomous system? You know, for an autonomous system, the solution curve is depend upon, is dependent, right, to the difference of time t and the initial time t naught. Okay, it is a function of t minus t naught. All right, so let us see, let us, you know, this one. So that one explanation of the parallel line. Okay, here again also let us see. Suppose you start, this is some fixed value of, you know, x, this is t axis, this is x axis. You start here, okay, you start here at time t is equal to 0, you start from here. Okay, this is a fixed point x. Again, then there will be one solution curve here. Okay, this is your solution curve. All right, so again at the same time, at the same point but different time, no, that will be here. So this is what, this is 0 x, okay, x naught, and this will be what, this is 1 unit of time, this is 2 unit of time. Here it will be what, x 2 comma x, this point is coordinate. So starting from this initial position, you think about one, you know, you think about one another solution curve. This will be like this, this will be like this. Okay, this will be like this. All right, so what is the idea? You take just one point of x fixed, and then at different time you will get two different point in the xt space or tx space. So taking that 2 point as an initial point, starting point, you think about two solution curve. One is this one, another one is this one. All right, so then for autonomous system, we are talking about for autonomous system. Okay, so this is the curve passing through this one, or this is the solution curve passing through this point, starting from this one, you know, and this is the solution curve passing through this, you know, this is the solution curve passing through this one. After a gap of time 2 unit. Okay, after a gap of time 2 unit, you start from here. Okay, same x level x. Okay, so then you think about this point, this is 1 unit of time and this is 3 unit of time. So what is the difference? 3 minus 1 is, you know, 3 minus 1, this much difference is what, 3 minus 1, it is 2 unit of time. Okay, so for autonomous system, you know, at this 1 unit of time, for the first solution curve, the corresponding point x will be given, you know, this one, this point is given by this one. Okay, this is the point on the x-axis, this is the point. All right, after a lapse of 1 unit of time, this point moves here or this point moves here. Okay, so again you just think about the second solution. Okay, starting from this one, so after lapse of 1 unit of time from here, so this is 2, after 1 unit of time it will be here 3. Okay, so this will be what, it will be here. So what does autonomous, for autonomous system property is that one, the distance between this point and this point along this horizontal line is 2 unit. Okay, this gap of 2 unit will be always there. So if you take gap here 2 unit, the gap here corresponding here will be 2 unit. So this point, you know, what I mean to say is that you can think about one curve like this, na, passing through this one. This cannot be solution curve. Okay, you can think about starting from here, you can think about one curve along like this, na. So then this and this unit, okay, all right, cannot be, you know, 2 or something like that. So therefore this cannot be solution. So this will be solution, so that the difference here is exactly equal to the difference here. Okay, So it is depend upon the difference of initial 2 point. So difference here is exactly equal to the difference here. All right. So this is the characteristics of autonomous system. This is the characteristics of autonomous system. So then again you think about 1 point here, another point here, okay, another point here. So if this is time 5 unit, if this is 7 unit, their gap is 2 unit, all right. Then you go up to the first curve, something you go up to the first curve, something will be here, and then this you go up to the second curve, something will be there, okay, point will be there. So their difference will be also this two units, okay, this gap maintained. That is why the slope here, the tangent vector here will be parallel to this tangent vector here. All right. So this is the characteristics of autonomous system. Okay. So today being Sunday, I don't want to speak too much. I want to stop here. So let us